Now we're going to talk about equivalent fractions. When we're talking about equivalent, we need to be able to define what that means. Equivalent starts with EQUI, or EQU, which is really similar to how the word equal starts. So equivalent means that it has the same value. So when we're looking at fractions and images of fractions, we want to figure out, do they have the same value or are they equivalent? So if we look at this first one, we're going to write a fraction for each one. The blue is one piece out of two pieces is shaded blue. So we have half shaded. For this green one, we have two pieces out of four. 1, 2, 3, 4 pieces shaded in. So now 2 out of the 4 are shaded. If we look at the pink one, we have 3 shaded pieces out of the total 6. So that would be 3/6. If we look at the last one, there are 1, 2, 3, 4 pieces shaded in out of 8 total pieces. So then I want to ask you, what do the fractions in the images all have in common? We can see that each of them has the same amount shaded. They're just represented using different fractions. But if we look at each of them, the bottom half of each of these circles is shaded, and the top half isn't. So we know that every single one of them is half, just represented in different ways. So that tells us that each of these fractions is equivalent because they're representing the exact same amount, the same value is shaded. If we look at these three, again we see that the same amount of red in each one, but they're represented in different ways. If we look at the first image, we have 1 shaded out of 4. The second one has 2 pieces out of 8 total pieces. And if we look at this next one, we have 1, 2, 3, 4 pieces shaded out of a total, if we count them up, there are 16 total pieces. All we did was we took the same size rectangle and we cut them up into different sized pieces, even with the same amount shaded. And what that means is that they are equivalent fractions. Here's another image of what that looks like. We see a number line all the way from 0 to 1 for both of them. And it's shaded all the way to the same distance. But you'll notice that the bottom has more hash marks than the one on the top. But if we identify the same ones, they're in the same place. Those two are in the same place. We've got another little mark here, all the way to the end. So the top one is split into just 1, 2, 3, 4 parts. But 3 out of the 4 are shaded. If we look at the bottom one, it's just split into many more parts. We've got 4 parts here, 4 parts here, 4 here, and 4 here. So 4 in each of the 4 sections is going to give us 16 total pieces. And we have 4, 8, 12 of them shaded in. But you can tell that the color goes the same distance. So that means that these two fractions, because they're representing the same value, they are equivalent. So let's break it down even more. What does equivalent mean? You see in the meme, would you like your pizza cut into 6 or 8 slices, Dougal? So we're taking an entire pizza, and he gets to choose if he wants them in 6 pieces or 8 pieces. Right here we have the 6 pieces. here we have the 8 pieces. But this is just Dougal's pizza. And he says, oh, just 6, Ted. I don't think I could eat 8 pieces. But the entire pizza is Dougal's pizza. It doesn't matter how many pieces they're cut into if he's still going to eat the entire pizza. So let's take a peek at this. If we shade in that, and then also shade in, actually we're going to do a different one. We're going to shade in this side of the pizza, okay? And also this side. We're going to make it match. So now when we're looking at this, we can tell that if Dougal eats the shaded side, or if he eats this shaded side, he's still eating half of the pizza, because half is here and the other half is left behind. Well, the first fraction is saying that we have 3 out of 6. Well, 3/6 we said is half. So if that's one half of the pizza out of the 2 halves total, there are 2 pieces. If we split it up this way instead, just down that line, and the same thing for this one, then when we compare, this second pizza isn't out of 6 pieces, it's out of 8 pieces. And we have 1, 2, 3, 4 of them that Dougal is going to be eating. So there are 4 out of 8. But we know that also half of this pizza is shaded in. So because they're representing the same amount, we can say that 3/6 is equivalent or equal to 1/2, which is equal to 4/8, because they're representing the same amount of pizza. Some good benchmarks to have when we're talking about equivalent fractions is knowing whether it's equivalent to half or not equivalent to half. Another benchmark is knowing if it's equivalent to 1 or not equivalent to 1. Okay, because that will help you understand how much of it do we have, how much of the total do we have. So when we're talking about the fraction 1/2, if we multiply this top number by 2, we're doubling the half that we have. That would give us 2 then. It's going to give us 2, which is our denominator. Okay? If it does match exactly what that denominator is, we know that we have half of it. The size doubled creates the whole figure. So if we look at 3/4, and we use that exact same process, 3 multiplied by 2, if we take that half, and we say that we have 3, and the other half is also 3, 3 times 2, or saying 3 plus 3, both situations give us 6. And if we look at this, it was out of 4. So if we doubled it, it wasn't equal to the total, so we have more than half because it's bigger than the 4. So we also know that 3/4 is not equivalent to half. If we look at the 3/6, 3 multiplied by 2 is equal to 6, and that is exactly what our denominator is. So because we can multiply the numerator by 2 and get our denominator, that's equivalent to half. Another way we can think that one through is by saying, well, if we take the denominator and divide it by 2, half of 6 is 3. And that's exactly what we have. We have 3/6, so that is equivalent to half. If we have 1/8, if we double it, because we would want the other half, that would give us 2. 1 times 2 is 2, and that's not equal to 8, so we know that 1/8 is not equivalent to half. And we can do that for all of these. So if we identify all of the fractions that are equivalent to half, if we multiply that by 2, that gives us 4. That's not our denominator, so 2/6 is not half. We also know that half of 3, 6 divided by 2, is 3. That's not our numerator. If we look at the next one, 14 divided by 2 is 7, which is also matching with 7 times 2, which is 14. So that means, yes, 7/14 is half. If we double the numerator, that top number, we should get exactly the denominator, the bottom number, if it's equivalent to half. If we take this one, 2 times 2, that doesn't give us 8. So 2/8 is not equivalent to half. We do the same thing for 2/4. 2 times 2 is 4, so we know that 2/4 is equivalent to half. 5/12, again, if we double 5, that gives us 10. 10 is not the same thing as 12, so we know that it is not equivalent to half. 9/10, we know that half of 10 is 5, and we have 9. So 9/10 is not equivalent. 4/8, half of 8 is 4, or 4 times 2, if we doubled it, would give us 8. So we know that we have 4/8. 6/12 is the same way. 6 times 2 does give us the 12, or 12 divided by 2 does give us 6, so we know that 6/12 is equivalent to half. 1/4, if we multiply that, we double the numerator, that would only give us 2. That's not the same thing as our denominator, so that one is also not equivalent to half. Okay, which one of these final 4 fractions is equivalent to half? Another good benchmark to know and be comfortable with is if it's equivalent to 1, meaning we have the entire thing. Remember, we said the bottom of our fraction is the total, and the top is the part that we have. So if we look at this one, 5 out of 1, we can also divide to see is it equivalent, meaning equal to 1. 5 divided by 1 is equal to 5. That's not the same thing as 1, so 5 over 1 is not equivalent to 1. 1 divided by 1 is equal to 1, so 1 ones would go on the left side. 0 divided by 1, we have nothing to split up, so that's equal to 0. So that is not equivalent to 1. 3 divided by 3, notice that the same number is in the numerator and denominator, that is equivalent to 1. 4 divided by 4 also equals 1. Which of these 3 fractions is equivalent to 1? Seven sevenths is equivalent to 1 because 7 divided by 7 is 1. When we're trying to make and create equivalent fractions, meaning they have equal value, we want to multiply the numerator, that top number, and the denominator, the bottom number, by the exact same number. So that way we're treating both of them equally. We're treating them fairly. So one number that we can multiply them both by is 2. If we multiply the numerator and denominator by 2, showing them in both places, we're just rewriting it or splitting the entire thing into more pieces. We're not changing the amount that we have, we're just rewriting what it looks like. And that's what we were doing when we started. We were just rewriting what it looks like. So in this first one, if we multiply both of them by 2, 1 times 2 is 2 because we were splitting this one piece into 2 instead. But then instead of just having 2 pieces, we also split that side into two pieces. So 2 times 2 is 4. Notice how those are true sentences. That's exactly what we're doing when we're creating equivalent fractions. So right here, that's going to give us 2/8. We could do the exact same thing, but multiply by a different number. If we multiplied by 3 instead, again, we need to show it in the numerator and the denominator. But then that would give us 1 times 3 is 3, 4 times 3 is 12. So 12 is also an equivalent fraction. Another number we can multiply by is 10. As long as it matches in the numerator, the top, and the denominator, the bottom, it won't change the value of our fraction because we're treating them both the same. The relationship between them remains the same. So this would give us 10 out of 40, so 10/40ths. So let's practice some of these. We want to create an equivalent fraction for 1/3. There are many different options we could do. We can multiply by 2, we can multiply both by 3, we can multiply the numerator and denominator by 4. We get to pick. So for this one, let's say we're multiplying by 7. It has to be 7 in both the numerator and denominator. 1 times 7 gives us 7. 3 times 7 gives us 21. You'll notice for B that part of it was already filled in, so we need to figure out what this relationship is. 6 multiplied by 3 gives us 18, so that means we have to multiply by 3 in the numerator because we have to treat them the same. So that would give us 15. The numerator and denominator operation has to match for it to have the same value. Same thing in C. We got from 5 to 20. 5 multiplied by what number gives us 20? Well, that would be 4. So if we multiply by 4 in the denominator, we also have to multiply by 4 in the numerator, which would give us 8. That means 2/5 is equivalent to 8/20. 5/8, if we multiplied the bottom by 4, we also have to multiply the numerator by 4. And that would give us 32 in the denominator and 20 in the numerator for a fraction of 20/32. For this one, let's say we multiply by 5. Again, if we multiply by 5 in the numerator, what do we have to multiply by in the denominator? It would have to be times 5, which would give us an equivalent fraction of 5, because we multiply straight across, tenths, because 2 times 5 is 10. But again, it only works if we do the exact same operation to the numerator and denominator. Notice how that matches in every single example. You'll notice that f is just the value 2. If we're trying to write an equivalent fraction to 2, that also means that we have to have that written as a fraction. We've been talking how this fraction bar line, if we're trying to rewrite or check to see what it's equivalent to, like we were here, we were dividing to do that. So this fraction bar line not only shows that it's a fraction, but it's also division. And that's what we're doing here. We're going to divide by some number in the denominator, and it has to remain 2. What number can we divide by where this will keep this the value of 2? That number would be 1. 2 divided by 1 is still 2 because they all stay together in the same group. 2 divided by 1 is 2. So now if we're trying to write an equivalent fraction to 2, we put it over 1, and then we can multiply by the same number in the numerator and the denominator. So let's say this time we multiply by 10 in the numerator and the denominator. That would give us 20 over 10. If we divide it again, we should get the value of 2. And when we say, or take 20 divided by 10, that does give us 2. So we know that those two are equivalent.